Hello students, welcome you to this video. In this session I am going to teach you the objective questions from chapter number 8, differentials and partial derivatives. Okay. So let's move on to the first question. A circular template has a radius 10 centimeters. So radius is 10 centimeter. It is a circle, right? That's more important. The measurement of radius has an approximate error of 0.02, error in radius, so that is dr, 0.02 centimeter. Then the percentage error in calculating the area of this template. So for percentage error or relative error, the easy method is you take log and take differential. Okay, so area of a circle is pi r square. So taking log on both sides, you will get log A equal to log pi plus log r square, apply power rule, 2 log r, right? So taking differentials, log A, that is 1 by A into delta A or dA, equal to log pi derivative 0, constant, plus 2 into log r 1 by r into dr. To find the percentage error into 100, right? So both the sides you multiply by 100. So dA by A into 100 is equal to 2 into dr by r into 100. Substitute the known values. So 2 into dr is 0.02 by r is 10 into 100. So 1 0 cancel into 10. So shift 1 digit, 0.2 into 2, it is 0.4%, right? So delta A or dA by A into 100, that is percentage error in area. So that is option number 2. Now let's move on to question number 2. The percentage error in fifth root of 31 is approximately how many times the percentage error in 31? So we have a question in this type, right? A general question. Percentage error in the nth root of, right? Any number, nth root of a number is approximately equal to 1 by n times, right? Percentage error in that number. So we are not bothered about the number. Number can be anything. It is 31 or 71 or 301, whatever it is. But this is what we need. Nth root. Instead of nth root, here we have fifth root. So nth root 1 by n times. So fifth root 1 by n 5 times. Okay, so that's answer. So instead of 31, they can change any number. Your answer remains same. Instead of fifth root, if they say 31st root, then 1 by 31 is the answer. Now question number 3. U equal to e raised to x square plus y square. Dou u by dou x, very simple question. Dou u by dou x. Differentiate partially with respect to x. So when we use partial derivative, partial differentiation, when it is a function of more than one variable, right? Several variables, we use partial differentiation. So here we have to differentiate with respect to x. So to differentiate with respect to x, treat only x as the variable, all other letters as what? Constants, right? So first this is of the type e raised to x type, right? So e raised to x derivative, e raised to x itself. Don't stop, into its derivative, x square derivative 2x, y square derivative 0. It's a pure constant. We are differentiating partially with respect to x. And e raised to x square plus y square can be taken as what? The question u. So already we have 2x and this is u. So the answer is 2xu. That is the second option, right? Now question number 4. V equal to log e raised to x plus e raised to y. The question is find dou v by dou x plus dou v by dou y. So we find dou v by dou x first. This is of the type log x derivative 1 by x into its derivative, right? With respect to x we are doing, so e raised to x derivative, e raised to x itself, e raised to y derivative 0, right? So this is dou v by dou x. So same way dou v by dou y is again log x type 1 by x into its derivative with respect to y. So e raised to x derivative 0, e raised to y derivative, e raised to y itself, right? So we have to add these two. So adding 1 and 2. So dou v by dou x plus dou v by dou y. Both denominators are same. So e raised to x plus e raised to y, and the numerator e raised to x plus e raised to y. Cancel everything. So your answer is 1, and that is option number 4. Now let's move on to question number 5. W equal to x raised to y. The question is, w is a function of x and y, right? Two variables. So you can use only partial derivative. Dou w by dou x. Dou w by dou x. So here you remember the two formula. The derivative of x raised to n. What's the derivative of x raised to n? N into x raised to n minus 1. And the derivative of a raised to x. A raised to x derivative a raised to x log a. So what is the difference here? A function raised to constant. Here constant raised to function, right? But here depends on, we differentiate with respect to what? Here with respect to x. X is the variable. So function raised to constant. So this type, right? Suppose dou w by dou y means you have to use this result, okay? So here x is a variable, right? Y is a constant. Say like x raised to 5. 5x raised to 4. N x raised to n minus 1. So here the derivative is y x raised to y minus 1. So third one is the correct answer. But suppose when you go for the examination, suppose they change the question. Instead of dou w by dou x, if they ask dou w by dou y, so we have to differentiate x raised to y. Differentiate partially with respect to y. Then y is the variable, x is the constant. Then it is of the type constant raised to variable, a raised to x. Answer a raised to x log a. So here x raised to y log x is your answer, okay? So x raised to y is w. So read the question very carefully and do, but here is no problem. Easily can do that. Now let's move on to the next question. Question number 6. F is e raised to xy, function of x and y. What they asked here, find dou square f by dou x dou y. By seeing this you can understand. We have to differentiate it 2 times, right? One time with respect to x, another time with respect to y. But which one to be done first? You have to start from this end. First you differentiate with respect to y. That is, first you find dou f by dou y. That answer you differentiate partially with respect to x. That only we write like this. Dou square f by dou x dou y. That means first you differentiate with respect to y, then differentiate with respect to x. If you reverse the order, normally they will be equal, but not always. They are equal only if the given function is continuous, okay? Okay, we go in order. First you find dou f by dou y. Dou f by dou y. Differentiate with respect to y. E raised to xy, e raised to x type. So e raised to x derivative, e raised to x itself. Into the xy derivative with respect to y we are doing. With respect to y is there. X is the constant and y derivative 1 because we differentiate with respect to 1. With respect to y, right? Now this answer you differentiate partially with respect to x. Differentiate this partially with respect to x now. So you will get dou square f by dou x dou y. We differentiate partially with respect to x. X is in both the terms, so you have to apply product rule. So when you apply product rule, first into, that is e raised to xy into derivative second, x derivative 1 plus second into x into derivative first, e raised to xy derivative, e raised to xy into the xy derivative with respect to x we are doing. So y is a constant, x derivative 1, right? So what is common in both e raised to xy? What's the remaining? 1 plus xy, right? And that is option number 2. 1 plus xy, e raised to xy. Now let's move on to question number 7. If we measure the side of the cube to be 4 centimeter, side of the cube, they didn't mention any letter, so we take it as a. Sometimes they give x, 4 centimeter. With an error in a, say delta a or dA equal to 0.1 centimeter. Then the error in our calculation of the volume is, so volume of the cube, it is a cube, right? Take differential, dV is equal to a cube 3a square into dA. Substitute the values. So 3 into a square, a is 4, so 4 into 4 16, into dA is 0.1. 3 into 16 is 48 into 0.1, so 4.8, that is volume, so centimeter cube, right? Cubic centimeter. 4.8 cubic centimeter, option number 4. Now let's move on to question number 8. So listen carefully this one. The change in the surface area, they asked the change in surface area, so that is delta S you have to find. Change in surface area, S equal to 6x square, so that is the edge they given us what, x, of the cube. When the edge length varies from x0 to x0 plus dx, so this is the change, okay, change in x, that is delta x. Delta x is equal to what? Dx. Delta x is equal to what? Dx. That is the change. Suppose 6 to 6.1. What is the change? 0.1, right? So instead here x0 to x0 plus dx. So the change is dx. So delta x is what? Dx. So what they asked here? Change in surface area. So differentiated surface area S equal to 6x square, right? 6x square. Take differentials, delta S equal to 6x square. If you differentiate, you will get 12x into delta x, right? Substitute the values 12 into, instead of x means the initial value, it is x0 into delta x is what? Dx. So 12 x0 dx, and that is option number 2. Now question number 9. Listen to this question. The approximate change in volume, so you have to find dV, approximate change in volume of the cube of side x meter. So volume of the cube equal to x cube, right? Caused by increasing the side. So change in side dx is 1%. 1% means 1 by 100, right? 1 by 100, or you can write it as 0.01. Change in volume they asked, so take differential now. So dV is equal to x cube, differential 3x square into dx. Substitute 3x is x itself, x square dx, 0.01. So into 3 you multiply 0.03 x square, right? So that is option number 3, that much meter square. Now question number 10. G of xy, G equal to 3x square minus 5y plus 2y square, x equal to e raised to t, y equal to cos t. So what they asked to find? dg by dt, right? dg by dt. So please listen here. dg by dt means you have to differentiate g with respect to t. But here g is not a function of t. G is a function of x and y, two variables, so you can find only partial derivative. You can find dou g by dou x, dou g by dou y. X is a function of t, single variable, you can find total derivative, right? So you can find dx by dt and dy by dt, right? But you remember like this, g to t, you have to start from g and you have to reach t, right? So g to t, it is not here, right? So how you can reach t? G to x, x to t, or g to y, y to t, right? So there are two ways. So remember, r means you put plus. So g to x, dou g by dou x, g to x and multiplication, and x to t, dx by dt. G to x, x to t, r means plus. G to y, then y to t, g to y, y to t. Hope you understood. Some places I put partial, some places total. When you differentiate g, since there are two variables, you must use partial derivative. When you differentiate x and y, single variable, use total derivative. Okay, so g to t we want. So g to x, x to t, or g to y, y to t. Okay, so it's easy. Now it's simple differentiation. So dou g by dou x, differentiate with respect to x. There are three terms. First term there is x, second and third there is no x at all. So derivative 0, right? So 3x square derivative 6x. dx by dt, x you differentiate with respect to t, e raised to t derivative e raised to t. Plus dou g by dou y, differentiate with respect to y. 3x square derivative 0, there is no y. Minus 5y derivative minus 5. Plus 2y square derivative 4y. Into dy by dt, differentiate cos t derivative minus sin t, right? So now we multiply So at the same time you substitute the values of x and y. X value e raised to t, y value cos t, right? So 6 into x value e raised to t into another e raised to t plus, you can multiply by outside there is a minus, no? Minus sin t into minus 5, minus plus 5 sin t. Then plus into minus is minus 4 into y. What is y value? Cos t. Then another sin t is there, right? Cos t sin t. Okay, so that's all. That's here we can simplify. E raised to t into e raised to t. What is that? E raised to t the whole square, right? E raised to t the whole square. A raised to m the whole raised to n is what? A raised to mn. So e raised to 2t. So 6 e raised to 2t plus 5 sin t minus 4 cos t sin t or sin t cos t. So that is option number 1. So I want to teach you in another simple way. Please listen here. The same sum can be done in another way. Listen carefully. If it is an objective question, okay, only for objective question you have to use the method what I am telling now. Please listen. So g equal to, you substitute first itself. 3 x square. What is x square? E raised to t the whole square. That is e raised to 2t. Minus 5 into y. What is 5? Y cos t. Plus 2 into y square. What is y square? Cos square t. Okay. Now directly you find dg by dt. 3 into e raised to 2t derivative. E raised to 2t into 2. Minus 5 into cos t derivative minus sin t. So minus become plus sin t. Plus 2 into cos square t. That is x square. X square derivative 2x. So 2 cos t into cos t derivative minus sin t. So first term is 6 e raised to 2t plus 5 sin t minus 4 cos t sin t, right? That's answer you are getting 6t e raised to 2t 5 sin t minus 4 cos t sin t, right? But this method if you use for 2 mark, 5 mark, they won't give mark, okay? So this is only for objective question. If you want, you can use this method, okay? This is only for objective, you have to use this. Other sums for verification, if you want, you can use it, okay? Otherwise, don't use this method. You go for the chain rule, okay? Now let's move on to the next question, that is question number 11. F of x equal to x by x plus 1. F of x equal to x by x plus 1. Then it's differential, very simple thing. Just to differentiate, attach one dx, that's all. So df is equal to, so product rule, quotient rule, x plus 1 square v into u dash x derivative 1 minus numerator into denominator derivative x derivative 1 derivative 0, right, into dx. So here this plus x and minus x cancel, so we are getting 1 by x plus 1 the whole square into dx, and that is option number 2. Next question number 12. U equal to x square plus 3xy plus y minus 2019. The question is dou u by dou x. After finding dou u by dou x, you have to substitute 4 comma minus 5. For x you put 4 and y you put minus 5. Differentiate with respect to x. X square derivative 2x. The second term x is there. 3y constant into x derivative 1. Other two terms there is no x at all. So derivative 0, right? So at the point 4 comma minus 5, the meaning for x you put 4. So 2 into 4 plus 3 into y value minus 5. So you are getting 8 minus 15 minus 7. So that is option number 3. Question number 13. The linear approximation for g of x. So g equal to cos x at pi by 2. That is our x naught. X naught is pi by 2, right? So immediately what you find, you differentiate it. G dash. Cos x derivative minus sin x. Now put that x naught at x naught equal to pi by 2. You find g equal to cos pi by 2. Cos 0 is 1. Cos 90 is what? 0, right? G dash, that is minus sin pi by 2. So that is what? Minus 1. The linear approximation For several variables also we have another formula, right? There we take partial derivative. Linear approximation L of x equal to g plus x minus x naught into g dash. Okay. X minus x naught into g dash, or first you write g dash into x minus x naught. Substitute the values g, it is 0 now after substituting the value, right? Plus x minus x naught is pi by 2 into g dash is what? Minus 1. By that minus 1 you multiply minus 1 into x, it is minus x. Minus into minus is plus pi by 2, that is minus x plus pi by 2, that is option number 2, right? Yes, now let's move on to the 14th question. W equal to one function given, then dou w by dou x plus dou w by dou y plus dou w by dou z. You find one term, then cyclically can rotate because it is a symmetric function. So you find dou w by dou x. First term x is there, so y minus z is a constant, x square derivative 2x. Second term also x is there, so plus y square is a constant, z derivative 0, minus x derivative minus 1. Third term also x is there, so plus z square is a constant into x derivative 1. So dou w by dou x is, multiply term by term, 2xy minus 2xz minus y square plus z square. This is dou w by dou x. Similarly, you can write the other two. We want dou w by dou y. What do you do now? That x, y, z cyclically you change. X, y, z. X, y, z. Instead of x, you put y, and y you replace by z, and z you replace by x. Because in the question, if you replace like that, there won't be any change. Only the term's position will change, but it remains same. So this become 2, x become y, the y become z. Second term minus 2, x become y, z become x. X, y, z, again x, okay? Z become x. Minus the y square become z square, plus z square after z x square, right? Then one more time you give change, you will get dou w by dou z. Here, this step, the previous step you give change. 2, instead of y you write z, for z you write x. Minus 2, instead of y it is z, instead of x it is y. Minus z square become x square, plus x square become y square. These are 1, 2 and 3. So add all the 3. Equation 1 plus 2 plus 3. Dou w by dou x plus dou w by dou y plus dou w by dou z. You will get, listen, these are the terms you have to add, right? Here plus 2xy, then minus 2xy, cancel. Minus 2xz plus 2xz. 2yz minus 2yz, right? Everything cancel. Here minus y square plus y square minus x square plus x square, z square minus z square, every term will get cancelled. So you will get the answer what? 0. Okay. So your option number 4. Okay, now let's move on to the last one, but that is possible only for symmetric functions. Okay. Look at the next one. F is given as xy plus yz plus zx. So first you find fx, right? Fx. Differentiate partially with respect to x. So first term x is there, right? First term x is there. So y constant into x derivative 1. Second term x is not there, so derivative 0. Third term x is there, z is a constant into x derivative 1. So that is fx. Next we want fz. So read very carefully. Sometimes don't take it as fy. It is fz, right? Read the question. Fz. Differentiate with respect to z. First term there is no z, so derivative 0. Second term z is there, so y constant into z derivative 1. Plus third term also z is there, x is a constant, x into z derivative 1. Now we see what they asked. Fx minus fz. Fx minus fz. Fx is y plus z minus of fz. So both the time you change the sign. Minus y minus x. Plus y minus y cancel. You are getting z minus x, and that is option number 1. Hope you understood all these things. Meet you in the next video.